Okay, so we're going to talk about projectile motion. So first of all, I'm going to actually rewrite both of these formulas so we can talk about what the variables represent in these formulas. Okay. So x of t equals, I'm just rewriting. You already have it at the top of those pages, and this is going to be written on the test. So your formulas for projectile motion will be given to you. All of this information here is on the test. So v sub 0 cosine theta t. So let's talk about this equation first. First of all, x, that represents a horizontal distance. So the variable x, so this equation we use for a horizontal distance. V sub 0, that's your velocity. Theta, that is your angle. T is time. So I'm just defining the variables in that equation. So the second equation, y of t, so you have negative 0.5 g t squared. I'm just, again, rewriting it. So this is a vertical distance. There are two different values for gravity. So G is gravity. G is gravity. And the gravity you're going to use is one of these two. It's either going to be 9.81 or 32.2. If it's in meters, if the distance, if the unit of measure for distance is in meters, we're going to use the 9.81. But if we're talking about feet, gravity, we're going to use the 32.2. So this G is one of these two numbers, depending on the unit of measure. T still represents time. So I'm not going to write that, but T is time. And again, you have the same variables as our horizontal distance. We have V sub 0, which is still your velocity. We have theta, which is still your angle. The only other new variable is H sub 0, which is your initial height. So the initial height of the object. Okay, so that's all of your variables. So I'll give you a second to copy that down. We're only going to have time to get through questions 1 and 2 today. So let's go ahead and look at question number 1. So the first thing we want to do for part A is write our equations. So let's write our x of t and our y of t. So let's go ahead and read that. It says a ball is kicked with an initial velocity of 60. So I got a velocity. Let me go ahead and underline that number. So my velocity is 60. So that's what I'm going to use for my v sub 0. The angle is 38. So we're in feet. So that tells me that I'm going to use the 32.2, not the 9.8. So let's go ahead and write our equations. So x of t equals, so we're just substituting in our variables. So it says v sub 0, which is 60, cosine of our angle, which is 38, t. That's my first question, my first equation. For my second equation, we have negative 0.5. So what am I going to use for gravity? Which G value am I going to use? Am I using the 32.2 or the 9.8? So 32.2. Then it's t squared plus 60 sine 38 t. Now, when in sports, or I shouldn't say in sports, but if you're kicking a ball, the initial height is 0. So we're just making the assumption, and I'm not a big sports person, but I don't know of any sports, and I'm not saying that there's not any out there, okay? But I will take a little venture out there and say that 90% of the time, you're going to kick it from ground level, okay? There's probably always some exceptions to the rule. So our initial height of the object is 0. So we're going to put a plus 0 at the end. So this is part A. So part A says write the parametric equations that will model the path of the ball. So this is part A in our notes. So what we just did was we wrote our parametric equations that will model the path of the ball. And I kind of like to draw out a little diagram as a reference. So we got her kicking the ball. So here's my ball. It's going to kick, and then eventually it's going to come back down. That's what happened. That's what's happening there. Simple. Okay. Part B says find the time at which the ball will return to the ground. So I don't know how far the ball is going to travel. But what is one thing that I do know about these 2 points? What do these 2 points have in common? So they both what? The vertical distance is 0. Okay? If it starts on the ground, the vertical distance is 0, and when it returns to the ground, the vertical distance is 0. So I'm going to use the y parameter and set this equal to 0 and solve for t. So let's use this equation right here and solve for t. So let's do that. So 0 equals, okay, if you type this in your calculator, let's go ahead and figure out what this number would be. What is negative 0.5 times 32.2? So we got negative 16.1 t squared plus 60 sine 38 t. And because my initial height is 0, I'm just going to drop that. So we need to solve this for t. The 2 times where the vertical height is 0. Does anyone know how I would solve this quadratic? No, we have to factor it. So this is a little bit of algebra. We could do the quadratic formula. That's a lot though, because this is factorable. Greatest common factor. What is my GCF? T. Let's take out the t. So 0 equals, let's take out the t. And then I have negative 16.1 t plus 60 sine of 38. So now I'm going to set them both equal to 0. So this here, when t equals 0, that represents when the ball was kicked. That's this one right here. So this one is already solved. So now let's take this factor and set that equal to 0. So if I take negative 16.1 plus 60 sine 38, that equals 0. Let's solve that for t. So in order to solve for t, I'm going to subtract 60 sine 38. So that's going to give me negative 16.1 t equals negative 60 sine 38. And then I'm going to divide both sides by negative 16.1. So I want you to take your calculators and type this into your calculator. And that's going to tell you the t value, how much time it took the ball to return to the vertical height of 0. So type that in your calculator, because it says find the time at which the ball will return to the ground. And I'm rounding out to the thousands place. So I got t is approximately equal to 2.294 seconds. So that's how long it took the ball to return to the ground. And that would be your answer to part B. Part C says find the horizontal distance. So now I'm going to use my x parametric equation, my x parameter. And because I know t, I can substitute this t value in for t in this equation for part C. So for part C, x, which is my horizontal distance, is going to equal 60 cosine 38 let me push that over a little bit so I have enough space. So x equals 60 cosine 38 times, and I'm going to use the answer I got in part B and substitute that in. So go ahead and type that in your calculator for part C. And you should get that the horizontal distance that the ball traveled is 108.8 462 feet. And that would be your answer to part C. This is the answer to part B. And then we have our equations. All right, go ahead and read question 2. And we're going to do it again. We're going to write a different set of parametric equations for the second scenario. Okay, so this one is a little different because we actually know how far away the ball needs to travel. Okay, we know that when Beth kicked the soccer ball, she was trying to hit a goal that was 60 feet away. So we actually know the horizontal distance. This is different from the first question because we didn't know the horizontal distance. All right, so let's start off by writing our set of equations. For this scenario, we need to know the velocity and we need to know the angle. So the velocity is 50 feet per second and the angle is 30. So 50 feet per second is your velocity and our angle is 30 degrees. So we're ready to write our set of equations. So for our first one, x of t equals our velocity, which is 50, cosine of 30 t. That's our horizontal distance. For our vertical distance, I need to take negative 0.5 times the gravity. And what gravity am I using in this scenario? Am I using 32.2 or 9.8? 32.2. So I'm kind of skipping a step. I'm just going to write negative 16.1. Does everyone understand where that's coming from? I'm multiplying that 0.5, the negative 0.5 times the gravity. So it becomes negative 16.1 t squared plus 50 sine 30 t. And again, not a big sports person, but we're kicking a ball, so the initial height is 0. So it says, how many seconds did it take the ball to reach the location of the goal? So when she kicked the ball, the goal was here. We want to know how much time it's going to take for it to travel. How many feet does it have to travel to reach the goal? 60. So let's take that horizontal parameter, which is x of t, because it's 60 feet away. So the horizontal distance between Beth and the goal is 60 feet. So we're going to use this equation, set it equal to 60, and solve for t. So 60 equals 50 cosine 30 degrees times t. And we're going to divide both sides. By 50 cosine 30. So So T equals 60 divided by 50 cosine 30. So go ahead and type that in your calculators. Take 60 divided by 50 cosine 30. If you're using the yellow calculator, because cosine 30 is on the unit circle, it's going to give you an answer in radical form. You hit the button above the enter key. It's going to switch that to decimal. So how much time, how many seconds did it take the ball to reach the goal? You should get that it took approximately 1.386 seconds. So make sure that's what you get. That would be your answer to part A. You should include unit of measures. So maybe a half a point, but I haven't thought about that yet, to be honest. What did you say? I didn't hear you. Okay, so above the enter, are you using a yellow calculator? Okay. You didn't get that? So I think I know what it is. So what you need to do is you're going to need to put parentheses in if your calculator doesn't have a fraction bar, you need to put parentheses. You need to put 60 divided by, then start a parentheses, because you have more than one thing in your denominator. So 60 divided by, start a parentheses, 50 cosine 30, and close it. So if you're using a calculator that doesn't have a fraction key, you need to include parentheses because there's more than one number in your denominator. Part C says, at the time the ball met the goal, what was the height? So if I'm looking for height, that's the vertical distance. Wait, what did I say? Oh, did I say C? Okay, sorry, B. Part B. At what time? Okay, so at the time that the ball met the goal, what is the height? So if you're looking for height, height is a vertical measurement, right? Would you agree that height is vertical? So we're going to take this answer that we got in part A, which is 1.386, and substitute it into my y equation for t. So let's take that equation. So y equals negative 16.1 t squared plus 50 sine 30 t. And now we're going to put that number, that answer that we got from part A, which is 1.386, and type that in your calculator. So type that in your calculator to see what you get for your vertical height. You should get 3.722 feet. Who got 3.722? So part C says, did Beth make the goal? So what do you think? In soccer, does the ball need to go over the net or land in the net? In the net, right? And how high is the goal? 5 feet. So if it is at 3.722 feet, that means it was less than 5. So would that count? So did she make the goal? The answer is yes. So the answer to part C is yes, she did make the goal. Okay, when I call your name, you can see your test from Friday. The deadline to retake that is 2 weeks from today. That's it.